3D printing is a hot topic these days because of the bright future it may create for all of us. You can see a 3D printer in action in the video shown here. Layer by layer, material is squirted through a nozzle and the product begins to form. Do you want to know more? Great. We will review the development of 3D printing, some of its capabilities, some of its risks, and where the technology is headed. So how did we get to the point of 3D printing? A look at printing history is a great place to start to answer that question. The origins of 3D printing is a relatively new technology. It all started in the late 1980s and it was called rapid prototyping technologies. This technology was originally developed as a fast, cheaper way to create prototypes for industrial use. The first patent for this technology was issued in 1986 to Charles Hull. Mr. Hull's first commercial rapid prototyping system, called the SLA-1, was released in 1987, and the first unit was purchased in 1988. During the 1990s and early 2000s, most technology being developed was for industrial use. Some more advanced technology providers, however, were researching for more specific tooling, casting, and direct manufacturing applications. By 2008, the medical field was using 3D printing to create prosthetic limbs, and by 2011, the accuracy of 3D printing had improved greatly and the overall price of each unit had dropped. While 3D printing may seem very complicated and difficult to understand, the main steps are very basic. You start by designing the overall object you want to create. This can be done by using special computer software such as CAD or a 3D scanner. Once you have designed and modeled what you want to print, you then need to get the 3D model ready to be printed. This is done by using software that will slice your model into thousands of individual layers. The printer prints the object layer by layer, so it is important that you spend time adjusting and getting the layer thickness right so the overall object looks as seamless as possible. The final step of the process is to print the object. There are 7 different methods of printing and various subcategories within each method. The different methods are vat photopolymerization, material jetting, binder jetting, material extrusion, powder bed fusion, sheet lamination, and directed energy deposition. Some of the categories are more common than others. 2 of the most common are material jetting, which is used to create Invisalign, and material extrusion, which is how scientists created functional organs that were implanted into mice. Since 3D printing is such a new technology, some of the kinks must be worked out. When printing, users may encounter one or more of the following: no extruding, under extruding, over extruding or a clogged extruder, stringing, overheating, gapping, curling, or scarring. Each problem is unique and requires different methods of troubleshooting. 3D printing, more commonly known as additive manufacturing in industry and business, has caught the interest of an untold number of fields: aerospace, the military, engineering, and architecture. Manufacturing like plastic screws and cell phone cases, even the art and fashion world is being impacted. One of the largest areas of progress and use would be in the medical and dental fields. Additive manufacturing is used in creating hearing aids, hip implants, dental crowns, and bridges. The preciseness of this technology, without having to mass produce, and the ability to utilize different materials such as a polymer, plastic, or metal makes it ideal for this field. Recently, a research program led to the creation of prosthetic mouse ovaries. They were created from collagen follicles with hormone-secreting cells and primordial ova. They were then implanted into the mice. In the 2016 Wohlers report, the additive manufacturing industry grew 25.9% and became a $5 billion industry. 3D printing has the potential to completely disrupt the manufacturing industry, similar to what automation did in the steel industry. 3D printing requirements will shift from the skilled worker to 3D printing technology, which means loss of manufacturing jobs. Additionally, it takes a different skill set and less people to maintain and operate 3D printers. When considering the effects of 3D printing in manufacturing, one must consider the economic impacts. As noted earlier, a shift in jobs will occur, replacing skilled workers with programmers, engineers, and software developers. Additionally, the way companies assemble, distribute, and store their products will change with the implementation of 3D printing. These factors combined will affect the economy as the laws of supply and demand will be at work. The future of 3D printing is very bright. In fact, the FDA recently approved an epilepsy drug called Spiritam made by 3D printers. Its approval demonstrates that the FDA considers certain 3D printed materials are safe for human consumption. Scientists anticipate artificial 3D printed ovaries could one day help infertile women get pregnant. As well, in the near future, prosthetics will be seamlessly integrated into people's everyday lives with minimal effort. New 3D printing technology sharply increases the size and number of objects that can be produced, offering new possibilities to remake manufacturing in the auto, aerospace, and housing industries. The automotive industry is a hive of rapid prototyping, fast development, and mass customization. It's a natural home for 3D printing. NASA is also currently developing the Space Launch System. This work will contribute to establishing on-demand manufacturing on long space missions while improving 3D printing methods on the ground. As we look to the future, it's clear that 3D printing has many benefits. However, we must also plan for any related risks. The use of 3D printing in manufacturing will create a shift in jobs, logistics, assembly, and warehousing, and therefore a subsequent shift in the economy. Will enough new jobs be created? Will 3D printing actually reduce the cost for the consumer? 3D printing in medicine has the potential to save many lives, but has the potential to open the doors to human enhancement and bring about ethical issues surrounding bioprinting.